All right, let's get you ready for your computer fundamentals exam. We're going to break down everything you need to know, focusing specifically on how to handle those multiple choice questions.
Okay, here's our plan. We'll start with the basic definitions, then see how computers actually work. After that, we'll look at some key comparisons that are super important for your exam. Then we'll do some practice questions, and finally wrap it all up with a quick summary of the most important points. All right, let's dive into Section 1, Core Concepts and Definitions. Getting these basics down is absolutely the first step to doing well in your exam.
So first up, we have hardware. And the easiest way to think about this is if you can touch it, it's hardware. Simple as that. It's the physical body of the computer, the monitor, the keyboard, all the wires and chips inside.
Okay, so if hardware is the body, what gives it life? Well, that's where software comes in. You can think of software as the brain or maybe even the soul of the computer. It's the set of instructions that tells all that physical hardware what it's supposed to do.
Now, right at the center of all the hardware, you've got the central processing unit, the CPU. People call it the brain of the computer, and for good reason. It handles literally everything. All the calculations, all the instructions. It's the powerhouse that makes it all work.
And the last key term for this section is GIGO. It stands for garbage in, garbage out. And this is a really important idea to grasp. It just means that the quality of the computer's output depends entirely on the quality of the input. If you put in bad data, you're going to get a bad result. The computer isn't making a mistake, it's just doing exactly what you told it to do with the information you gave it. So remember, most computer errors are actually human errors.
Okay, so we've got the basic terms down. Now for Section 2, let's look at how computers actually work. We'll see how all those pieces fit together. Basically, everything a computer does follows this simple four-step process. Think about it like this. Step 1 is input. You press a key on your keyboard. Step 2 is processing. The CPU figures out what you did. Step 3 is storage. The computer holds onto that information for a split second. And Step 4 is output. The letter you typed appears on the screen. Input, processing, storage, output. It happens over and over, super fast, for everything you do.
So what makes computers so powerful? It really comes down to these 5 things. First, speed. They can do billions of things per second. Next, accuracy. They don't make mistakes, but remember, GIGO. They only work with what we give them. Then there's diligence. A computer never gets tired or bored. It can do the same task a million times perfectly. They're also incredibly versatile. You can use the same machine for so many different jobs. And of course, storage. They can hold huge amounts of information. You'll definitely want to know these 5 for your exam. Of course, not all computers are the same. They come in different shapes and sizes for different jobs. What you're looking at here is a mainframe. Think of these as the giant workhorses for big companies like banks, processing tons and tons of transactions. Now for your exam, you really need to know the difference between 3 main types. A mainframe, like this one, is for big business data. A supercomputer is for super complex scientific stuff, like weather forecasting. And a microcomputer, well, that's just a personal computer, a PC, like the one you're probably using right now.
Okay, let's get into Section 3. Now, this part is really important for your MCQ exam. We're going to focus on comparing concepts that look similar but are actually very different. These are the kinds of things they love to ask about, so paying close attention here can really make a difference. All right, here's a classic exam topic, the difference between primary and secondary storage. You can see the main points in the table. Primary storage, which is basically RAM, is super fast, but you get less of it, and it costs more. Secondary storage, like your hard disk drive, is slower, but it's cheaper and you can store way more stuff on it. But out of all these differences, there is one that is the most important one to remember for your exam, and that's volatility. Okay, here's your MCQ alert. RAM is volatile. You absolutely have to remember this. Volatile just means that as soon as the power is turned off, anything in RAM is gone. It's completely erased. That's why you always have to save your work to the hard disk. The hard disk is non-volatile, so it keeps your data even when the computer is off. And here's another common comparison you'll see, impact versus non-impact printers. The key word here is impact. An impact printer, like an old dot matrix, actually hits an ink ribbon to make a mark on the paper. That's why they're so loud and pretty slow. Non-impact printers, like the inkjet or laser printers we use today, are the opposite. They spray ink or use heat so they don't have to physically touch the paper. This makes them way quieter and faster. Just remember, impact means it touches the paper. Okay, we've covered the concepts. Now it's time for Section 4, where we put what we've learned to the test.
let's work through some practice questions that are very similar to what you'll find on the actual exam. Here's our first question. It's asking which part of the CPU is the one that actually does the math and the logic. Take a second and read through the choices. The correct answer here is C, the Arithmetic Logic Unit, or ALU. And the clue is right there in the name, arithmetic for math, and logic for logical operations. Now let's look at why the others are wrong. The control unit, A, just directs traffic. It tells everything else what to do but doesn't do the calculations. The memory unit, B, just stores things. And the registers, D, are just tiny, fast storage spots. The ALU is the only one that does the actual work. Okay, question number 2. Let's break down the important clues here. They need to print on multi-part forms, the cost has to be very low, and it says noise is not a concern. So, which printer is the best fit for all 3 of those things? And the answer is C, a dot matrix printer. This goes right back to what we talked about with impact versus non-impact printers. To print on multi-part forms, you need a printer that physically hits the paper to make a mark on the copies underneath. That's an impact printer. Laser and inkjet printers can't do that. Plus, dot matrix printers are super cheap to operate, so it fits all the requirements.
Great job on those questions. We're on to our last section now, a final high-yield summary. This is a super fast review of the absolute most important things you need to remember for your exam.
Okay, here we go. These are the absolute must-knows. The CPU is the computer's brain. Hardware is what you can touch. Software is the set of instructions. RAM is primary storage, and it is volatile. It forgets everything when the power goes off. The hard disk is secondary storage, and it's non-volatile. It remembers. Input devices put data in, output devices get data out. And finally, GGIO, garbage in, garbage out.
And that's it. We've gone through the core concepts, how things work, those tricky comparisons, and even some practice questions. You now have a solid grasp of the fundamentals. You are ready for this. Good luck on your exam.